Okay, this is part 3 of the lecture on Python classes and objects. And part 2 ended a little bit abrupt, and I will pick up where I left. So I was talking about accessors and mutators, which is really accessor is get name, returning the hidden attribute from my insect class in this case, and mutators is set name, and this is something you will need to know. And the importance of these methods, if I was seriously defining set name, I would need to check that what the user supplies over here is actually a string and not a number. So I would validate the input. And actually, I might want to do it here as well, checking that name is actually not a number, but rather a string. Because look at this, what I define here in the string method. I define here a sum of two strings, presumably, so I will need to make sure this is a string. So that's why it's important to not be able to supply the attributes directly and instead go through this routine with set name and get name for every attribute that there is. All right, so let's finish quickly through the slides. And yes, passing objects as arguments. You can look it up in the book. I actually just showed you the example how to do that, and that's what you will need for the question about farmers in your homework. Farmer class. You will create farmer class, and you will let farmer 1 talk to farmer 2. And farmers will have name and also like a mood index, a numeric value of the mood. And depending if if your farmer is in better mood than the other farmer, then or the other way around, so something happens with this mood index, it goes up or down. So that was an embedded introduction to the homework. That should be fun for you to do. All right, and so techniques for design in the class, and that is actually much bigger than what we have over here or what this book will include. The next chapter of this book that we are not going to cover probably is inheritance, and beyond that there is coupling of classes, there is design patterns, and keep up with the software development program here at BIPSI, and you will learn a lot more about those things. UML diagram by itself, it will look to you like very little thin unified modeling language, but imagine that you are working with a bunch of classes, and for example, we have a class coin, it will have an attribute side up, and it will have methods that are listed in the last box. And if you have a bunch of different classes for your project, you will connect each of these little diagrams with another diagram and explain what the connection is. So that's how UML diagrams used, and this is what you will need for your quiz, but I'm not going to rely on it. We are not going into the classes and subclasses, for example, at all. And finally, there is a discussion that you also need for the quiz of how to understand what your classes should be for a certain project. Well, you should have a description of your project, and you should hash out with the your manager or with the customer what your project is about, down to a rather good amount of detail. And then you analyze what are the nouns, and first of all, nouns, what are the nouns that are repeated in your project, and that are your candidates for classes. And how those nouns are used, the verbs that come next to those nouns, maybe, not necessarily, but maybe your methods that you will need, public methods with these classes. Just like we did with an insect, we wanted to have a public method cage, and you could easily come up with some other public methods, how two insects can interact with each other, how an insect can change or things like that, interact with another object from a different class, completely different class, for example, flower class or vegetation class. And that is how you go about identifying what classes are. And for attributes, data attributes, you will need to think what the class knows, quote unquote knows, what the class should store, what kind of information it should store. And that is how you decide on your attributes. So we only talked about two standard methods, string and init. And we talked about hiding attributes, and we talked about the meaning of self-parameter. And that's it for with the theory. I would really like to dive into code. So let me start. Oh, this is Insect Online. There is a little bit too much. Oh, I need to close that. We're not going to reference back to it, except for remind you again that this is something similar to what you would need to do for your weekly homework. All right, I'm restarting everything. Okay, and this will be a account module. So the module can store, and often does, stores a class, and then from a different program, from a different file, I'm going to load this module, and I'm going to use my bank account, for example, in a program that is called, I don't know, just work with your bank account, something like that. Okay, so I have some code started. I did this whole thing with my in-person students, but yeah, I'll just borrow a starter code from there. Init is what every class is supposed to have. Name, that will be the name of the account holder, and initial amount will be the amount that the account holder is putting in when opening an account. So for now, it's going to be just two attributes, and then I'm going to add a much more fun and sophisticated attribute. Well, the most basic things about accounts, we need to withdraw and we need to deposit. I want to have some string statement about the account, and already I can start debugging it. I can create an instance from the account for debugging. So whatever I write over here is for debugging only. So my account will be equal to bank account with the name Vlad and amount 1,000 of whatever units, dollars. So name is Vlad and initial amount is 1,000, and self, now that I created this instance, in this instance refers to my account, my variable. So to this particular object. If I create an account for someone else, in that particular case, self will be referring to that other account. And in general, understand that the object comes with attributes, the data that you supplied, and it comes with some form of it does know about this code. It does know about withdraw, deposit, and string, and whatever I created, whatever other method I created before initializing my account. And just for debugging again, I'm gonna print my ec and see that it works, just to make sure. So far, nothing amazing happened about this account. So this is Vlad's account with balance 1000. So notice this is a string, self-name is a string, and then uh, apostrophe s, account with balance. And before I can use the variable self amount, self double score amount, I need to convert it to string as well, because otherwise the sum, meaning concatenation of the strings, will not be defined. So far everything works. This class is a little bit too poor. We did not even do withdraw and deposit. And over here I plan to do away with getter and setter. I might want to do the getter for the name, but there shouldn't be other ways to, probably in my account, I don't want to have other ways to set the amount or get the amount, just withdraw and deposit. So that is a little bit of my decision making. And how do I withdraw? I will need, for withdrawal, I will just take care of this variable. Take care of this variable. I will decrease it minus equal to value. And you can think if this is good enough. And there goes my print statement. I will say withdrawal, withdraw, and then value. And yes, you probably guessed what is wrong with this. If not, keep thinking about that. Withdraw value, and then I'll say just left, amount left. Self amount. So I changed self amount, then I just made a printing statement. What can possibly go wrong? How to use this and what can possibly go wrong? Keep playing with my account. Dot withdraw 300. Let's run, see what's going on. By now you should be yelling at the screen what's going on. Everything is fine for this input. How about I want to withdraw 3000? So now I have a huge overdraft. I got a lot of cash. I can run away with it. So that's not the behavior that we want for the function withdraw. So I'm going to do if compare self amount to value. If self amount is bigger or equal to value, then actually do the withdrawal. And the printing statement. And we will have to do an else. Print insufficient funds, and that's all for now. We are going to come back to it and modify it to make it more fun. So now let's see that it works better. So you see that I need to debug all the time. I need to debug very often to make sure everything works and catch minor errors, indentations, and such. You should be as well. Okay, so we weren't able to withdraw more than we had. Okay, and deposit is just self amount plus equals to value. Anything can go wrong there? Think about it while I'm actually typing it up. Well, I did not think of any scenarios where anything can go wrong, so let me just do a deposit. $400. So this should come with some sort of printing statement. Like current amount, maybe a better way to call it. Deposit amount new total maybe, or let's call it new total is self dot double underscore amount. So this is a little cute class, and I can double check that it works. It's not anything to write home about. I'm going to add a getter setter for name just to conform with the common theory about. Here we go. So I just copied it from the previous project. This is kind of a trivial pulp, and I'm not having initial getter and setter for initial amount. I just decided that, unless there is a requirement for me to do that for some reason. And there may be legitimate reasons to do that in case my bank accounts interact with each other. That would be a next, like one of the upgrades that we can do, like send money from one account to another account. Okay, I want to show you a different development here. I want to have account history. That's a reasonable thing to have. Account history will be another attribute, and it will store a list. So whatever happened, the withdrawal or unsuccessful withdrawal or something else like that, deposit, it should be reflected in history. So self history equal to, and now we have to work together to understand what the history should be. I said it's going to be a list. We will append as things will be happening to the account, such as withdrawal. We will have to append information to it. So my unit of information to append in case of withdrawal will be what happened, withdraw, like the word withdraw, and also the new amount. Just report the new amount, that would be sufficient. Okay. So this will be my list, and initially when I'm creating the account, I might store the history, but in the name in the history, but I store it separately, so that's okay. I want to store this. First of all, a string, initial amount, and then actual amount, initial amount. So that's how I'm initializing my variable history. It's first of all a list consisting of a tuple. This highlighted thing is a tuple, so I will have a list of tuples in the end when I add things to the history. So each history record will be string on the first position, initial amount in the second position. All right, so now deposit. I want to withdraw, and I want to append something to the history there. Okay, so self dot double underscore history history dot append. That's how you deal with a list. You can append to it. This is a list, right? This reference is a list. More specifically, it's a variable that is reference in a list dot append, and here goes my tuple. First of all, I'll say withdrawal, and what I'm going to add there is just what happened after the withdrawal, so current amount. Just to keep my history brief, you could want to add more to it. So I'm appending another tuple, so I will have eventually a list of tuples. And very similarly, I will change something when I'm successfully depositing. Append deposit and then the new amount. So that will be good enough. However, in case I withdraw successfully or I append successfully, I deposit successfully, I'm appending another tuple consisting of a key value pair. First will be a string, like what happened, and second will be the current amount, not the amount I deposited, but the current amount on my account. And yes, you could disagree with my choices, you could criticize me for not doing something. In the case of insufficient funds, so that is not reflected on my history. Obviously, there are some shortcomings to what I have done so far. But let us check that it works, and well, let's run it. Still runs okay. Unfortunately, as of this very moment, I don't have any way to access history or know what is in the history. It's a private attribute of my bank account class. It is initialized at this point, and some things were appended to it, but nothing can be printed. There is no way to access it. I could do a simple getter to get the entire list, or I could do something more sophisticated. I can do def c history, and I will need to do self because that refers to the object that I'm going to be creating. And in this case, first of all, I can just print this. I can print this or I can return this, and that will be some way of looking at it, but however, not very convenient. I want to go into for item, first of all, for item in self dot double underscore history, and you can think what it means as I'm typing it. Print item. I'm doing it iteratively so that it is easier for you. And finally, I'm going to do my account and call see history on it. So my account dot see history does not take any arguments. Self is the default argument referring to self. Let's run and see what it does. So the last thing I called is see history. Initial amount was 1,000. Deposit, I deposited, and it was 1,400 after the deposit. Okay, so I can even elaborate on my history. Instead of printing an item, I can do event a word event, then print the event that happened, item 0. So each of my items is a tuple. Now I'm using the fact that I created this self-history in a very systematic way as events. So event will be whatever happened here. And then the next one will be current amount. And that will be the amount, which is baked into, guess what? Stop the video and think what I should do next here. What is the logical next thing? Item 1. So now I will probably have a prettier see history thing. There we go. So this is my history. Initial amount, event. Maybe instead of initial amount, I should say initial deposit here, and then event deposit, current amount 1400. Okay, so just to make it prettier, deposit. And I could do this with tab character just to make it look a little nicer. Let's rerun and see what happens. So I'm beautifying for now. Well, not much of a beautification happened. I should shorten this a little bit. Let's rerun. Hopefully it will line up. Yeah, now it looks prettier. And as things happen with the account, there will be more things, more history to print. So this was for debugging, and I guess I'm done developing my class for now. If you guys want a good exercise to prepare for your homework is to try to send money from one account to the other account. You will have to create another account, and then you will have a public method transfer between the accounts, and it will debit from one account and credit it to the same sum to another account. And if you're cool, you can even like take 1% for the transfer or whatnot. So there is definitely ways to develop this. I think it is quite cool the way it is. So what I want to do next, I want to use that module. So first of all, import bank account. And then I will have a little while loop that will first of all create an account for a person, and then single account to make it easier, and then do things with it such as withdraw, deposit, and see history. I'll pause the video because that is something that you are more familiar with. All right, just to see, for you to see the intermediate step of this development, what did I do? I import the file account module. Before I do that, I need to delete everything that I used for debugging it, or at least comment it out. No real reason to delete it completely. Just comment it out, and I hope it won't print it. Some shells might actually print that. Anyway, name and initial deposit, that's what we're asking from a user, and we are creating the account, the bank account. So notice how I'm referencing the class account module, the name of the file that I imported, dot bank account, that is the class, and I'm supplying the variables that I asked the user to provide earlier, such as name and initial deposit. So let's run and also print my account just to see what's happening. This is not yet what we want, probably. So account program, let's save it like this, and okay. See, it printed what was before. Think why it happened. That's important for your final project, by the way, to understand why that happened. Enter your name, Vlad. That is where my current program is actually running. 100. This is Vlad's account with balance 100. Cool. So the question remains, why it still prints this stuff, executes this stuff, even though it was commented out. Notice this little star here, it means it was not saved. So make sure you save your module in the current form before you are importing it. So now, if I rerun it, so let me just rerun it. Sorry, I'll close this run. Account module ran, and now I want to run my program on top of it. Run that. Enter your name, Vlad, your deposit 100. Here we go. The account was created as expected. All right, so give me a moment for the usual while loop and an if statement about what is going to happen. All right, let's look at this intermediate step of the development. I need to add a question about the action. You can read this code for now. So I introduce the action variable 0 to quit, 1 to withdraw, 2 to deposit, 3 to print history. And I'm doing this little trick that some of you may have done already and learned about online. While true, this is kind of non-break in the loop ever here, but there is a special break statement that happens in case the action equals 0, and I print by, and then I break. So you can break the loop with while. Maybe better to be careful and describe the action you want for breaking the loop. And at this point, I'm just going to do it like this. All right, so the while loop and if statement, this is one if statement, by the way. Ask yourself if this is everything we need for an if statement. Maybe there is something I'm missing. And so far, I'm not doing anything for action 1. I just have pass, which means I'm going to develop it later. I want to run it, not get any errors, just to check that it runs. So my name is V, deposit is 1, and I will enter 1, then I will enter 0, and my program quits. So this is me testing my while loop and a little bit and seeing that everything works as intended. So this is like an alternative design for the while loop with while true, and then inside it you do a break depending on condition. It has pluses and minuses, so I just felt like showing you something different this time. So in case my action is 1, that is withdraw, I need to call my account withdraw. That's why I didn't want to delete this, guys. So my account withdraw. And instead of 3000, I need to think, where do I get the value? Where do I get the value to put in here? I got to ask. So I'm going to ask for an amount, float input, enter the amount you want to withdraw. And I'm going to pass this amount as an argument into my function. And as I'm doing that, I might as well want to debug it. And before that, maybe I want to actually copy the other things as well. So in this case, I'm just, in case of C history, all I need to do is to copy that. I'm not asking the user for anything in case I want to see history. That is option 3, see history. So that should be fine. And in case of a deposit, I will need to ask the user again, the person, how much this user wants to deposit. So let me see. Where can I copy that quickly? Yes, here. I will just edit this line real quick and call this deposit. And what I'm doing with it, I'm passing it here as an argument, deposit. All right, so almost everything works now. Let's run and see how it runs. So enter my name, enter my initial deposit. So to withdraw, I want to withdraw 100 insufficient funds. Okay, that works for me. I want to deposit 200. I want to deposit 30. I want to withdraw. Let me make this full screen. I want to withdraw 40. And finally, I want to print history. So this is all my history except for unsuccessful withdrawal. And that seems to be working just right. So all I want here is to quit. And that is my example. So just to walk you over what happened here, let me show you account program. At this point, we no longer care what is account module. All we care about is how to initialize it, how to create a particular account object with initial deposit and name. And then we need to interact with it using public methods, withdraw, deposit, and see history. And that's about everything we needed to know about account module. And the big ideology here is that somebody could have gone back to account module and changed the way this public methods work, or the way the information is stored in history completely, and yet your program will still work exactly the same. As long as, say, this printout looks exactly the same, you can still see your history. So if the data is parsed and printed in the same way, you won't even know that I went back there and I changed something about my history attribute. Or maybe I did away without history attribute and I stored my information in a different fashion. So that is the good thing about this. And yes, here is the class. I wrote the class in this way. Definitely it could be developed, and this program could be developed as well. We could call this program an ATM, although I'm not sure you can start an account at ATM. I never tried. I did not use ATM for years, probably now. Okay, so that's all for this example and for this video. I hope it was fun and instructory. And again, this while loop, well, while loop is something like what you want to do starting your final. Please do start working on your final project. You don't need to use classes on your final project specifically. I do recommend using a dictionary though. And to work with this dictionary and to decide on actions instead of a class with methods, which you could do, I just want you to call a function on this dictionary, and this function would change the values, change the change the dictionary values, and that will be the way the information is stored in your uh, program. And look back at that introductory video that I made. So at this point, you should be working on your final project.